Morning. Today we're going to work on the binomial theorem. It begins with this thing called Pascal's triangle. Now, when you take your statistics class, they'll get into more details of how to break this stuff down. We want to do a practical example and show you the power of binomial theorem and how it can work with statistics. But this is the basis for it. If we come over here, we can see some complicated math that goes with it. These equations are pretty good when we have highly powered equations like this, like a plus b to the seventh, and we can use binomial theorem to do some higher level math there. Once again, we want to move on beyond this math and get to a practical example. Here's some more here. What I want to get to is right here, finding these binomial coefficients. We really want to focus in on this combination right here, which we've seen before in our P's and C's. And we want to use that and the binomial theorem to figure out some practical examples. Right here is a real-world example. I can turn my screen sideways now so you can see the whole equation. It says the probability that Andres gets a hit when at bat is 1/5, or a batting average of 200. What is the probability that Andres gets exactly 4 hits in his next 10 at-bats? And we can see all the math that they do here. I want to show you how to do this, actually run the equation and break it into its pieces. So let's move over to our sheet here. And we can see here, there's our formula. Our combination formula is the total amounts at bat. His pass rate, that's the P. And then we need from his statistics, what is his normal pass rate and what is his normal fail rate. And then we put up here, that's going to be, right up here is going to be another P, the pass rate. And this will be the total minus the pass rate for his fails. Okay. To get that fail rate statistically, his batting average is 200. To get his fail rate, it would just be 1 minus that, or 100% minus his batting average, which will give us his 0.8. Bring this down to the equation, plug everything in, and we get a combination 10-4. We put in his pass rate, which we get from his statistics. In this particular one, we want to see how what's the chances of him doing it, being successful 4 times and failing 6 times. We're getting 4 hits and 10 at-bats, so we have this thing set up. We move down to the equation here. If we were to set up the first piece, this area right here, we have to do a combination. If I come down here and I do it by hand, this is how we do a combination. Remember the exclamation point is just we expand out from 10 times 9 times 8 all the way down to 1. In this case, we have, that's going to end up being a 6 factorial. There's our 4 factorial. Get that for our down there in our denominator. Up here, numerator, 10 factorial. If I take these down, 10 times 9 times 8, I get to the 6 factorial here. And I have a 6 factorial here and a 4 factorial. Now I expanded the 4 factorial, but those two 6 factorials, they're going to cancel each other out. So I can go in here and just get rid of that. And that can go too. And I'm left with those numbers there. If I put those into my calculator now. Let's bring the calculator in here. I've already done these equations. We move up here. There's my 10 times 9 times 8 times 7. Gives me 5,040. 4 times 3 times 2 is 24. And I end up with 210. All right. That 210 now is multiplied by those other 2 pieces in the equation. I'm going to take the calculator away. I still have to combine this right here, this 210. That 210 still multiplies into those right there. Okay, if I bring it down to the bottom of the page, I've written this out a little more neatly. I've taken that combination there, and I have my equation. Pull the calculator out again, and I end up with an answer of 0.88. So about approximately 9% of the time, someone who's batting 200 will get 4 hits out of 10. Some people will ask, how do you put this into your calculator? Right here you can see how that works. This is an older TI-84. I'll show you what it looks like on a newer one. That's the equation we put in there. Now if I were to, let's do this equation, show you how to do it on the older one real quick. These are a little harder to do. I have to put my n in first, which is going to be my 10. And then I go to math. And then I'm going to slide over to probability. Number 3 is my combination. And then I put in my final number, which was the 4, and enter. And I get my 210. On the newer ones, if we come over, this is a newer one here. I'm going to go over to my calculator here. If I go math and move over to my probability numbers or functions, move down to 3. Okay, and hit enter there. So it conveniently gives me the blocks to put the numbers in. This makes it a lot easier to do. So I can put my 10, slide over and do my 4, and hit my enter, and it gives me my 210. Okay, that's the example from the book. My next video will be the example on the worksheet.